Hey, what if I told you that using this, you could get this? Let's try something first. Well, that didn't work. Give me a sec. Now just trust me here.
While this may seem like a randomly thrown pile of spaghetti, which it is,
Magic here depends on the random pattern of spaghetti that intersect the lines of chalk.
now imagine our chalk lines from earlier extended into infinity at a distance t from each other.
When we randomly throw our spaghetti needles of length L when L is less than T, what is the probability of the spaghetti needles intersecting one of the lines?
This problem, Buffon's needle, is one of the earliest examples of geometric probability and was first proposed by George Leclerc, the Comte de Buffon, a French nobleman.
To find the probability of intersections, we must first find two random variables that can describe the position of the needle, x and theta. X is the distance from the needle to the closest parallel line, and theta is the acute angle formed by the needle and parallel line. We can assume that these variables follow a uniform distribution, meaning that each outcome is equally likely to occur and are independent of each other, meaning that x and theta do not affect the outcome of each other. And because distance and angle of the fallen needle are independent, the joint density function will become the product of the two uniform distributions. Lastly, we must add a geometric condition that the spaghetti crosses the parallel lines, which is a value of x that is less than or equal to L sine theta over 2. By integrating the joint density function, we can now solve for the probability of intersections, which we find to be equal to 2L over pi t. Now we have a way to estimate pi. Now we just have one unknown left in our equation. However, we can easily solve for the left-hand side of the equation by doing many more simulations of many more spaghetti sauces. To do so, let's toss some spaghetti onto these evenly spaced parallel lines here. Let's say that out of 12 spaghetti needles, 3 of them intersect a parallel line. Plugging that into our equation, we get 3 over 12 equals 2L over pi t. Now, assuming that t is twice the length of L, we can plug that in for L and t and cancel out the 2's, getting that 0.33, 3 over 12, equals 1 over pi. Now, rearranging the equation to solve for pi equals 1 over 0.33, which is approximately equal to 3.03.
And this is how I turn spaghetti into pi.